Okay, in this example, how many atoms of oxygen are contained in 500 dot grams of Fe2SO43? Alright, so we're going to start off with 500 grams of 500 dot grams Fe2SO43. We'll do times in a line. Now we know grams of Fe2SO43 is going to be on the bottom. Now what I will need to do here is I need to figure out where I need to go. Now I know that I need atoms of oxygen, but there's no way that I can get from atoms of oxygen to grams of Fe2SO43, at least not in one step. So what I think I'm going to have to do is go to molecules of Fe2SO43 first. And then I can go to atoms of oxygen using this relationship here, the fact that there's a certain number of atoms in one molecule of this. Alright, so I'll find molecules first, which means I need a relationship between these. And the relationship is I've got 6.022 times 10 to the 23 molecules. And that's going to equal a certain number of grams, and that number of grams is the molecular weight, 399.95 grams of Fe2SO43. Alright, so that will allow the grams here to cancel and allow us to get molecules. So that tells us how many molecules of Fe2SO43 that we've got. Now what we need though is the number of atoms, of oxygen atoms there. And then what we'll have to do is we'll have to do times. Now I know molecules of Fe2SO43 go on the bottom. And what we're after though is atoms of oxygen. And the relationship here is we know there's 12 atoms of oxygen in one molecule of Fe2SO43. So that's going to allow us to calculate all that out, and we'll end up with our answer, which will end up having three significant figures. 9.03 times 10 to the 24th atoms of oxygen will be our final answer there. Okay, in the next one, it's asking how 246 litres of SO2 gas at STP would have what mass in grams. So we're going to start out with 246 litres of SO2. We know that litres of SO2 is going to have to go on the bottom here, and we know grams of SO2 is going to go on top because that's what we want. And we've got a relationship here as molecular weight in grams is equal to 22.414 litres of a gas at STP. So we've got the molecular weight here at 64.07 grams, and that's going to equal 22.414 litres of SO2. Alright, so just looking at that, we know that that equals a mole, and we know that this equals a mole. Therefore they equal each other, which allows us to put them one over the other like this, and we can say that 64.07 grams of SO2 would indeed take up that volume of gas at STP, because they each have a mole. Now, as far as significant figures go, we've got three sig figs here. We'll have three sig figs in our answer.